When identifying appropriate classes, a good understanding of the system domain is important. The software developer often gains this through discussion with the client, assumed to be an expert in the area. The figure shown is an example of a DVD library system. The DVD library holds DVDs of a number of films. It may have any number of copies of each film. The system should, for each film, hold the film's title, and no two films have the same title. A library member can borrow any DVD of a film that is not currently on loan. However, no member can have more than 6 DVDs on loan at once. A borrowed DVD must be returned within 3 days. When a library member returns a DVD, it immediately becomes available for loan to other members. Each DVD has a unique identifying number. Each member of the library has a unique membership number, that is, the system also holds each member's name. An association between two classes is a set of links that have a common meaning. You have seen that a link is a connection between a pair of objects, one from each class, that is significant for the system domain. For example, in the DVD library system, each film object may be linked to a number of DVD objects, with each link between a single film object and a single DVD object representing a connection between a film and a DVD. The situation at a particular point in time can be illustrated by an object diagram as shown. The links on the figure shown are said to be instances of an association which exists between the classes film and DVD. In practice, the identification of associations often proceeds in parallel with the identification of classes. As an example, here again is the requirements document for the DVD library system. The figure shows the possible association between entities and their attributes. The number of instances of a class that can be linked by a particular association to a single instance of the class at the other end of the association is known as the multiplicity of the association at the end. For example, suppose that each student on a particular course must have a single tutor and that each tutor must be assigned to 20 students. The multiplicities of a tutor association between the class's tutor and student would be shown as in the figure. When discussing the associations for the DVD library system, we noted that a requirements document frequently provides information about the number of links that are possible between objects of particular classes. For example, a member of the DVD library may, at any point in time, have any number of loans between 0 and 6. The class diagram for the DVD library system showing multiplicities for the is-to association is shown. The multiplicity of the is-to association at the loan end is 0 to 6 and would be indicated on the class diagram by writing 0.6 on the is-to association next to the loan class. Although a member may have a number of loans at a particular time, each loan will be linked to only a single member, so the multiplicity of is-to at the member end is 1. An invariant is any condition on the objects of a conceptual model, their attribute values, and links, which must hold for the requirements to be satisfied and the consistency of the model to be guaranteed. Such a condition represents a constraint on the real-world entities modeled. We start by illustrating this concept with some examples from the hospital system. Consider the following extracts from the requirements document for the system. Each patient is under the care of a single team of doctors. A patient may be treated by any number of doctors, but they must all be in the team that cares for the patient. These extracts both imply invariance that must be true of our model at all times. Each patient object must be linked to one team object, not zero, not more than one. All the doctor objects linked to a patient object must be linked to the team object to which that patient object is linked. We can express these two invariants more precisely as follows. Each patient object is linked to exactly one team object. If a patient is any patient object, then any doctor object linked to a patient is also linked to the team object, which is linked to a patient. The first of these invariants imposes a condition on the number of links that are allowable between objects of two classes. The second invariant is one such example. It expresses a dependency between links of more than one association. The need for invariance in a conceptual model arises from the fact that the entities in the system domain may be interdependent in a way that is not evident from their representation in the conceptual model's class diagram and class descriptions. Where there are constraints on some aspect of the system domain, an invariant spells out the conditions that ensure that this constraint is reflected in the model. Some invariants express a relationship between two or more elements of the model. For such invariants, it may be possible, given the values of one or more elements, to work out the value of some other element. For example, consider the hospital system. For each patient object, the value of its age attribute is equal to the difference in years between the current date and the value of its date of birth attribute. And, knowing both the current date and the value of a patient object's date of birth attribute, it is possible to work out the value of the patient age object's attribute. Just as there is a relationship between invariants involving attributes and derived attributes, so it is the case that invariants involving links of different associations may indicate that one of those associations can be derived from the others involved in the invariant. Now, consider the case of a particular patient object, say patient 6, linked via the association to a team object, say team 3, which represents the team that cares for the patient. Team 3 will link the consultant doctor object, say consultant doctor 5, which represent the consultant doctor who heads that team. What the invariant expresses is that the particular consultant doctor object to which patient 6 must be linked must be consultant doctor 5, as shown in the object diagram in figure. You may wish to attempt the following learning activities. Their possible solutions are provided at the top of the Player tab. Thank you.